Good morning, grade 8. Our lesson today is about using pressure in liquids. In this lesson, we wanted to know how hydraulic machine works and also what are the uses of this hydraulic machine. First, we must know that the hydraulic machine uses liquid to produce very large force. So why the hydraulic machine uses liquid? Because the liquids are incompressible, and this is very important point you must highlight it here. So we use liquid because liquids are incompressible, as you can see. Unlike the gas, we can compress the gas. So here, if you are going to notes here, you are going to find that liquid here inside the hydraulic machine. Okay, why we use this liquid? Because liquids are incompressible. Now, what is the main idea of hydraulics that we are going to see now? In general, hydraulics consists of two terminals, as you can see here. This is the first one, and this is the second one. One of them thin, or the cross-section area is small, and the other one, the cross-section area is bigger than the first one. And by the way, this is called the piston. This is piston 1, 2 pistons, and this is piston 2. Here, these pistons are movable, so we can apply here a small force on piston 1 will lead to a big force on the second terminal or on the second piston. So if we are going to apply with a force on piston A, this makes a pressure that pushes the piston B upward. So if we are going to apply a force of 2,500 Newton on the first piston, which is piston A, or the master, it's called also, it has another name which is called the master piston, and the area of the first piston of 0.1 meter square, and here piston 2, the area of piston 2, 0.5 meter square. So we can calculate the force that's produced on the second piston. So first we are going to calculate the pressure on the first terminal or the first piston. So pressure equals, as you know, equal force divided by area. And we have here the force 2,500 newtons and also the area 0.1 meter square. Now the pressure equals 25,000 Pascal. Let's see the pressure on the second one. In the hydraulics, this pressure, which is 25,000 Pascal, will transfer from the first terminal to the second one. So the pressure also will be on the second terminal or the second piston will be 25,000 Pascal. Now we can calculate the force because we know the cross-section area or the area of the second terminal. So force equal pressure multiplied, as you can see, force equal pressure multiplied by cross-sectional area. So force on the slave piston, which is the second one, okay, equals 25,000 multiplied by 0.5. So the force will be 12,500 Newton. This is produced from a force which equals 2,500. So as you can see, the force enlarged. So we have the force, we apply the force of 2,500 Newton. This leads to a bigger force which is 12,500 Newton. And this is the main idea, as I told you, of the hydraulics, to enlarge the force. So we apply small force and they get large force because the pressure transfer from the first terminal to the second one. Now let's see another example from your book. This is book page 156. You are going to see here we have a left hand diagram, and this diagram shows that we are exerting by a small force on the first piston, as you can see here, and this piston moves down here, okay, and makes a pressure or produce pressure. This pressure transfer from the first one here, this is the red arrow of the pressure, to the second one, which is the second piston, and rise the piston up. Now here let's see this example with numbers. We have here force of 10 Newton, and we have piston A, the cross section of piston A equals 20 centimeters square, and here piston B, the area equals 400 centimeters square. Now let's calculate. We have first we must calculate the pressure, okay, and then we are going to use this pressure to get the force or to calculate the force. So now here the pressure equals force divided by area, and force equals 10 Newton. So here, look at the last part here. Okay, so pressure equals force divided by area. Force 10 Newton divided by 20 centimeters square, so it will be 0.5. This is the pressure, 0.5 Newton per centimeter square. Now we are going to use this pressure. Here we are going to use the pressure to get the force, and we have here the force at B. Force equal pressure multiplied by area, and here we have the pressure 0.5 Newton per centimeter square multiplied by 400 centimeters square, which is the cross section of the second piston, and here the force will be 200 Newton. So here the force has increased from what? From 10 Newton to 200 Newton, okay? So this is, as we said, this is the main idea, so highlight this point here. The force has increased from 10 Newton at A to 200 Newton at B, because B has a bigger area. As we said, the force that's produced at B is bigger. So as the area increase, also the force increase. Here piston B is 20 times bigger, so the force is 20 times bigger. Okay, so now the hydraulic jack is called a force multiplier. Why it's called the force multiplier? Because it increase or enlarge the force. And you know the hydraulic jack used to carry or lift cars. Okay, here that's enough for today, and next time we are going to talk about hydraulic brakes, hydraulic press. Thank you for listening, and goodbye.